Hello students, welcome to the physics class. Myself Srimati Deepa Deshnur. So in the gravitation topic, today we are going to see the numericals. Before going to the problems, we shall look at the formulas. The equation for acceleration due to gravity is small g, acceleration due to gravity is equal to g mm. G is gravitational constant, mass of the earth divided by the radius of the earth if we are calculating acceleration due to gravity on the surface of the earth. Then value of g at height, if we are calculating the acceleration due to gravity at some height above the earth's surface, then g dash is equal to 1 upon g into 1 upon 1 plus h by r the whole square, or g dash is equal to, this is for small heights. For small h value, it means if the h value is very less compared to the r value, like 200 kilometer, 400 kilometer, r is 6400 kilometers. So with respect to that, if h is 200, then it will be considered as a small value. In that case, you can use this formula. If h is having the higher value, like 1000 kilometers, 1200 kilometers, 2500 kilometers, 3000 kilometers, then you can use the first one to calculate acceleration due to gravity above the earth's surface at some height. Acceleration due to gravity below the earth's surface, that is at some depth d. So gd, gravitation acceleration due to gravity at depth d, is g into the bracket 1 minus d by r, depth from the surface of the earth divided by radius of earth. Escape velocity Ve is under root 2g in the bracket r plus h. If the object is launched near the surface of the earth, then h value is neglected, or h is taken as 0. If we are throwing the object from above the surface of the earth, then from what height we are throwing, that is the h value. Potential energy of the satellite is minus g mm. M is mass of earth, small m is mass of the satellite, r is radius of earth, and h is the height of the satellite, height of the orbit from the earth's surface. Orbital velocity, with what velocity the satellite is revolving around the earth or around the planet. Root of gm divided by r plus h. So gm value, from here we can write gm is equal to g r square, g into r square. So if it is on the surface, then it is r we have to take nearer to the surface, h will be neglected. If h is having considerable value, then r plus h the whole square. Then time period of a satellite. To complete one revolution around the earth or around any planet, the time taken by the satellite is calculated by this formula. Capital T is equal to 2 pi under root of r plus h the whole cube divided by r plus h the square. When this cancels, r plus h, only that much remains in the bracket. The first question: calculate the force exerted by the earth on the moon if mass of earth is 6 into 10 to the power 24 kg, mass of moon is 7.4 into 10 to the power 22 kg, and distance from moon to earth is 3.84 into 10 to the power 8 kilometers, 10 to the power 5 kilometers, and Gravitational constant is 6.7 into 10 to the power minus 11 Newton meter square per kg square. So this formula is based on gravitational Newton's law of gravitation, Newton's law of gravitational force. So what all are given? We are asked to calculate the force between the two objects. The force between the two objects is equal to the gravitational constant into mass of one object into mass of second object divided by the distance between two objects. So what all are the quantities given? Mass of M is nothing but mass of Earth, capital M. Mass of the moon can be taken as small m. And this distance between moon and Earth is taken as capital R. So substitute the values in this equation. G value is 6.7 into 10 to the power minus 11 into capital M value 6 into 10 to the power 24 into small m value 7.4 into 10 to the power 22. The whole thing divided by R value is 3.84 into 10 to the power 5, but the value is in kilometers, so it should be converted into meter. So kilo value is 10 to the power 3. So altogether it becomes 10 to the power 8 the whole square. So when you substitute, when you calculate, you are going to get the value 20.2 into 10 to the power 19 Newton. So this force, by this force, the earth attracts the moon as well as the moon exerts the gravitational attraction on the earth. The second question is, calculate mass of earth with the given values. So what all are the given values? They have given acceleration due to gravity value and radius of the earth. Only these two quantities they have given, acceleration due to gravity and the radius of the earth. So with these two values, which equation we can use among these? Which equation we can use wherever mass of the earth is included? So here mass of the earth is included, but RH is not given, but it is equation for velocity. Velocity is not given. So here the mass of the earth is included in this equation, but energy is not there. So in this equation there is no mass of the earth. So here too, in these two equations also mass of the earth is not there. So in this first equation mass of the earth is included. So we can use this equation, but let us see where we know do we know the other values? Yes, we know the R value, radius of the earth they have given. We know the G value, and capital G value is a universal constant. Sometimes they may give the value, they may not give the value. You have to remember it. So what is the G value? G value is 6.7 into 10 to the power minus 11. So which possible equation that we can use is acceleration due to gravity is G m divided by r square. But in this equation, what is the required value? The m, mass of the earth. So let us rearrange the equation for the m value. M is equal to G r square divided by capital G. So substitute the value. G value is 9.81 into R value is 6.37 into 10 to the power 6, the whole square. r square, then divided by 6.7 into 10 to the power minus 11. So when you substitute these all values, the value you are going to get for mass of earth is 5.97 into 10 to the power 24 kg. 5.97 into 10 to the power 24 kg. Let us move on to the next question. So here, the acceleration due to gravity at a depth d reduces to 25% from the value at the surface. ಅಂದ್ರೆ earth surface ಮೇಲೆ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಇರ್ತೈತಿ ಅದರದ್ದು 25% ಇಳಿಕೆ ಆಗ್ತೈತಿ. reduces to 25% from the value at surface. Calculate value of g if radius of earth is 6400 kilometers. Value of g on the earth surface ಕೇಳಿದಾರವರು. earth surface ಮೇಲೆ ಎಷ್ಟು ಇರ್ತೈತಿ. Calculate the value of, it is the value of d. It is the value of d. ಅಂದ್ರೆ ಯಾವ ಡೆಪ್ತಿಗೆ ಎಕ್ಸಲರೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ಸರ್ಫೇಸ್ ಮ್ಯಾಲಿಂದ್ರಕ್ಕಿಂತ 25% ಕಡಿಮೆ ಆಗ್ತೈತಿ ಅಂಥೇಳಿ ಯಾವ ಡೆಪ್ತಿಗೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ವಾಟ್ ದೇ ಹ್ಯಾವ್ given acceleration due to gravity at certain depth is 25% of the g value. 25% of g value. Then 25% means it will be 25 divided by 100 of g. It is gd. Or you can get gd divided by g. If you take g on the side, it will be at the denominator. gd by g is 25 by 100. The ratio you are going to get is 1 divided by 4. So let us consider this as equation 1. Now write the equation for acceleration due to gravity at some depth. Value of d at depth d is gd is equal to g into 1 minus d by r. Acceleration due to gravity at some depth d is g into 1 minus d divided by r. So g, if we take on the other side and substitute the value, gd divided by g is equal to 1 minus d by r. But from equation 1 we can get gd by g value as 1.4. So it is 1.4 is equal to 1 minus d by r. So if we rewrite the equation, it will be d divided by r is equal to, if we take d divided by r on this side, it will become positive. 1 by 4 on the other side, it becomes 1 minus 1 by 4. 1 minus 1 by 4. So d by r is equal to 3 by 4, or d value is 3 divided by 4 into r value, which will be equal to 3 divided by 4 into 6400 into 10 to the power 3, because the value is in kilometers. We have to substitute in meters. So kilometer to meter, to substitute you have to write 10 to the power 3. So when you simplify, you're going to get d value as 4,800 kilometers. So when you go at a depth of 4,800 kilometers below the Earth's surface, the value of acceleration due to gravity reduces to 25% of its value on the surface of the Earth. The next question is, calculate the acceleration due to gravity at height 2500 kilometer above the surface of the earth, whose radius is 6400 kilometer. Given small g value is 9.8. Now look at the value of h. H value given is 2500 kilometers. So it is not a small value, it is a little bit a greater value. If the h value is 200, 800, within 1000, then you can consider that h as very small value. See, value of g at height h. So if the height is greater, g into 1 plus h by r the whole square, you can use this equation, or for small h you can use the second equation. But as h value is 2500, you have to use this equation to calculate the acceleration due to gravity above the surface of earth. So acceleration due to gravity above the surface of earth, acceleration due to gravity above the surface of earth is g dash is equal to g divided by 1 plus h by r the whole square, h by r whole square. This equation is for large h value. For large h value. Now substitute the values. G dash is equal to, g value they have given as 9.8 divided by 1 plus 2500 divided by 6400. Somehow both are having the kilometer, that is into 10 to the power plus 3, get cancels, the whole square. So g dash is equal to 9.8 divided by 1 plus 0.39 the whole square. So this 10 to the power 3, 10 to the power 3 get cancels, 0, 0 get cancels, it is 25 by 64. When you calculate 25 by 64, you are going to get 0.39. So 1 plus 0.39 the whole square, or g dash is equal to 9.8 divided by 1.39 the whole square. 9.8 divided by 1.93, the square value is, when you divide it, you are going to get g dash value as 5.07 meter per second square. Acceleration due to gravity above the earth's surface at a height of 2500 kilometer will be 5.07 meter per second square. Meter per second square. So look at the answer. Every answer is having a unit. So you all know the marks distribution pattern. Writing the equation, proper equation, you will get 1 mark. For substitution, 1 mark. For calculation, 2 mark. And for the final answer with unit, 1 mark. So totally the marks distribution will be for 5 marks. Now let us go to the next equation, next question. The question is, calculate orbital velocity and period of revolution of an artificial satellite of Earth revolving at a height of 200 km from Earth's surface. So orbital velocity ಮತ್ತು time period artificial satellite ಎರಡೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ, ಆರ್ಬಿಟಲ್ ವೆಲಾಸಿಟಿ ಮತ್ತು ಟೈಮ್ ಪೀರಿಯಡ್. ಸೊ ವಾಟ್ ಆಲ್ ಆರ್ ದ ಗಿವನ್ ಕ್ವಾಂಟಿಟೀಸ್? ರೇಡಿಯಸ್ ಆಫ್ ದ ಅರ್ತ್ ಕೊಟ್ಟಿದ್ದದ 6400 ಕಿಲೋಮೀಟರ್, ಮಾಸ್ ಆಫ್ ಅರ್ತ್ ಕೊಟ್ಟಿದ್ದದ, ಆಮೇಲೆ ಗ್ರಾವಿಟೇಷನಲ್ ಕಾನ್ಸ್ಟಂಟ್. ಸೊ ಇಕ್ವೇಷನ್ ಅಂತೂ ಗೊತ್ತಿದ್ದದ. ಇಲ್ಲೇ ಆರ್ಬಿಟಲ್ ವೆಲಾಸಿಟಿಗೆ ನೋಡ್ರಿ gm r+h ಅದ. ಸ್ಮಾಲ್ ಜಿ ಕೊಟ್ಟಿದ್ರೆ ಈ ಇಕ್ವೇಷನ್ ಯೂಸ್ ಮಾಡ್ಕೋಬೋದಿತ್ತು. ಕ್ಯಾಪಿಟಲ್ ಜಿ ಕ್ಯಾಪಿಟಲ್ ಎಮ್ ಕೊಟ್ಟಾರ, ಈ ಇಕ್ವೇಷನ್ ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು ಆರ್ಬಿಟಲ್ ವೆಲಾಸಿಟಿಗೆ. ಆಮೇಲೆ ಟೈಮ್ ಪೀರಿಯಡ್ಗೆ 2π ರೂಟ್ ಆಫ್ r+h the whole cube divided by r+h the whole square. Okay, so let us calculate the orbital velocity first. So orbital velocity value is v naught is equal to root of capital G into m divided by r plus h. ಈ ಇಕ್ವೇಷನ್ ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು. ಇಲ್ಲ ಇನ್ನೊಂದು ಇಕ್ವೇಷನ್ ಏನದ, ಜಿ ಎಮ್ ಅಂತಂದ್ರೆ ಕ್ಯಾಪಿಟಲ್ ಜಿ ಎಮ್ ಅಂದ್ರೆ ಜಿ ಇಂಟು ಆರ್ ಪ್ಲಸ್ ಎಚ್ ದ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್ ಪ್ಲಸ್ ಎಚ್. ಸೊ ಇದೊಂದು ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ. ಸೊ ವಿ ನಾಟ್ಗೆ ಏನು ಉಳಿತೈತಿ? ವಿ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೂಟ್ ಆಫ್ ಜಿ ಇಂಟು r plus h, root of g into r plus h. So when you substitute the values, v naught is equal to, g value is 9.8 into 6400 plus 200 into 10 to the power 3, ಯಾಕಂದ್ರೆ 2 ಕಿಲೋಮೀಟರ್ ಒಳಗಿದ್ದಾವೆ. So when you substitute, v naught is equal to 8.04 kilometer per second. It has 8.04 kilometer per second. So this is the orbital velocity. So you can use this gm divided by r plus h the whole under root. If you use that formula, the same answer you are going to get. So the next sub question to calculate time period. Capital T is equal to 2π root of r plus h the whole cube divided by r plus h the whole square. So ಇದು ಒಂದು ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ. ಎಷ್ಟು ಉಳಿತೈತಿ? T is equal to 2π root of r plus h ಉಳಿತೈತಿ. 2π ನಾವು ರೂಟದ ಒಳಗೆ ತೊಗೊಂಡ್ವಿ ಅಂತಂದ್ರೆ, 2π ನಾವು ರೂಟದ ಒಳಗೆ ತೊಗೊಂಡ್ವಿ ಅಂದ್ರೆ ಸ್ಕ್ವೇರ್ ಮಾಡಿ ತೊಗೋತೀವಿ. ದಿಸ್ ಇಸ್ ಜಿ ವ್ಯಾಲ್ಯೂ ಹಿಯರ್. ಸೊ ಡಿವೈಡೆಡ್ ಬೈ ಜಿ. ರೂಟದ ಒಳಗೆ ತೊಗೊಂಡ್ವಿ ಅಂದ್ರೆ ಎಷ್ಟಾಗ್ತೈತಿ? ಟಿ ಈಸ್ ಈಕ್ವಲ್ ಟು 4π ಸ್ಕ್ವೇರ್ r plus h the whole thing divided by g ಅಂಡರ್ ರೂಟ್. ಸೊ ಇಷ್ಟಕ್ಕರದ್ದು ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ 4 ಇಂಟು 3.142 ಸ್ಕ್ವೇರ್ ಇಂಟು 6400 ಪ್ಲಸ್ 200 ಇಂಟು 10 to the power 3 divided by 9.8. ಇಷ್ಟಕ್ಕೂ ರೂಟ್ ಹಾಕಿದ್ರೆ ಆನ್ಸರ್ ಏನು ಬರ್ತೈತ್ರಿ? 5.2 into 10 to the power 3 seconds. 3 seconds ಇಷ್ಟು ಟೈಮ್ ಪೀರಿಯಡ್ ಬರ್ತೈತಿ. ಇದು ಅಲ್ದ ನೀವು ಇನ್ನೊಂದು ಏನದ ಅಂತಂದ್ರೆ, ಟೈಮ್ ಪೀರಿಯಡ್ ಅಂತಂದ್ರೆ ಆ್ಯಕ್ಚುಲಿ ಫಾರ್ಮುಲಾ ಈಸ್ velocity is distance divided by time. So time period is, if you rearrange this, distance divided by velocity. So time period is, T is time period to complete one oscillation, Distance is the distance of one rotation. Velocity is with what velocity it is rotating. So distance for one rotation is the circumference is nothing but 2 pi r divided by velocity with which it is rotating is orbital velocity. So T is equal to 2 pi, r value is nothing but capital R plus H divided by V naught. Substitute the value, it is 2 pi, r value is 6400 plus 200 into 10 to the power 3 divided by V naught. V naught value is we have already calculated in the previous sub question. It is 8.04 into 10 to the power 3. On the substitution, you are going to get 5.2 into 10 to the power 3 seconds. So this is the time period. So these are few equations, few numericals based on the gravitation. So practice these equations. Along with this, you can practice some other numericals on the gravitation. Note down these all equations.